Hello everyone. In this session, we'll deal with chapter 3, which is very, very interesting and very important for design point of view. In chapter 3, which is physics used in HVAC. And you know this, without this concepts, you cannot think to deal with this designing part for this HVAC, especially for the load calculation. And when we deal with the fluid mechanics or this say ducting, piping, all these concepts is required. So in chapter 3, physics used in HVAC, we'll start with the heat. And you see, if you're dealing with the air conditioning, so air conditioning, the first parameter, adding or removing the heat, right? So it must to understand what is heat. So we'll start with the term heat. Then we'll discuss about the temperature and the temperature scales. Then we'll also talk about this sensible and latent heat. And we'll deal with this vapor compression cycle, refrigerants, loss of thermodynamics, units and conversion, all this topic in chapter 3, and which is very basic and very, very important for design point of view. If you know this concept we can use at the time of designing, especially this sensible heat, latent heat, temperature scales, units conversion are very, very important. Okay, and we'll deal with the vapor compression cycle, which is required at the time of chapter 4 when we deal with the classification of machines, because in all commercial and residential units, you'll find vapor compression cycle only, right from this window to chill water chillers. Okay, so this is very, very important. So I know this is very basic, but we cannot ignore this because without this, it's difficult to deal with the load calculation or the designing part. So let me proceed. So here, the first term you can find is the heat. And you see, we are dealing with the air conditioning, adding or removing the heat as to maintain the required temperature for summer or winter. So first of all, you must know what is heat. And as a mechanical or as an engineer, I believe you already know the heat, but my responsibility is to explain this quickly because as I said, this course, what we design is from basic to the advanced level. So you know about this terms and terminology, but in this session, we'll try to understand this terms and terminology for application point of view. Okay, not just theoretical. We'll try to understand for application point of view. Then only you can involve in the designing because concept is very, very important. So here on screen, heat is what? In short, I can say heat is a form of energy. And temperature is what? Temperature and heat both are same or different?
Different.
Yes, heat is a form
Temperature
of
is
energy.
different. Yes, sir.
So heat is a form of energy and temperature is the intensity of that energy.
Yes,
Okay,
sir.
so with the temperature, we can find out the rate of heat transfer, but the content of heat, the content of that energy is a heat. Okay, or else the heat we can also call in technical term as enthalpy, right? Heat content of the body. So what exactly heat? You can find out here on screen. Heat is a form of energy transfer that occur between the substance with a different temperature. And you know this, whenever there is a temperature difference, then only the heat will transfer. No? If the temperature, if it is same in both the bodies, and if it is physically connected, that will attain what? Thermal equilibrium and will not transfer the heat. So heat will transfer only when there is a temperature difference. If there is no temperature difference, there will no heat transfer because both the body will attain thermal equilibrium. And this term also will use at the time of load calculation, especially at the time of learning heat gain through partition, floor and ceiling, because heat gain through partition means between the two rooms. If the two rooms with the same temperature, it means there will be no heat transfer. Okay, so just I'm trying to relate these terms with the load calculation so that when we deal with the load calculation, this will be useful or this will be helpful for us. Next, heat can be transferred through conduction, convection and radiation. So I believe you know what is conduction, convection, radiation. If you are electrical, even electrical engineers also know these basics. But still, if you have confusion, don't worry. We have a topic in the next page only about this conduction, convection, and radiation. So the heat can be transferred with the different modes. This we can call as a different modes of heat transfer. It can be conduction, convection, or radiation. And it's a fundamental concept in thermodynamics. And you know what is thermodynamics? It's responsible for changing the temperature of object and can be measured in units like BTU. So as an engineer, you know calorie, joules, kilojoules, etc. What you learn in the engineering. But this term BTU may be new for many, those who are new to this field. Those who already in the field, they know this term is very commonly used in actual practice. BTU. BTU is what? In short, we used to call BTU. It's a British thermal unit, right? So what is BTU and how to understand this, that also we'll discuss. Let me proceed. So you see, heat always transfer from high temperature to, the low temperature. No? According to which law? This heat transfer from high temperature to lower temperature. According to which law or which thermodynamic law?
First law of thermodynamics.
Any more? Okay, it's according to second law. Anyhow,
law.
we have this laws of thermodynamics also, first and second law. In this chapter 3 only, we'll discuss before dealing with the vapor compression cycle. Okay, because this basics very, very important. So try to understand the applications out of this. And you see this heat transfer from high temperature to low temperature, this applicable at the time of learning vapor compression cycle, because in vapor compression cycle, you'll find condenser and evaporator. So in condenser, heat will reject, and in evaporator, heat will extract. And because of this, this nature of the heat only. Okay. So by nature, heat will always flow from high temperature to the low temperature, right? Everyone aware of this. We'll discuss more about this in second law of thermodynamics in chapter 3 only. Next, as I said, the unit of heat is a BTU commonly in actual practice. It can be joules, it can be calories, but most commonly in actual practice. This is actual practice means I'm talking about for this load calculation point of view. We're using this term BTU. So if you talk about the units of measurement, you know, SI units or English also known as imperial. Commonly, we are using this two measurement system in actual practice, SI, and metric is a part of SI, and English or imperial. So this BTU is a unit belongs to English system, and in SI we can use joules. Okay. So what is exactly BTU? We'll try to understand, because at the time of load calculation, when we extract the heat gain through all the possible sources, the end result is going to be in BTU per hour. So we must know how much BTU per hour is adding for a particular space. Then only we can able to select the required capacity cooling unit. Or in case of heating also, we must know at what rate the heat is rejecting from the space. Again, that we are calculating in terms of BTU if we are dealing with the English system. So what exactly BTU is? In case of conversion, you see 1 joule equal to 0.000948 BTU, or 1 BTU in terms of joules is 1055.06 joules. This is the values, but what exactly the BTU? That we'll try to understand now. Okay, so you see, even this calories also will be used, which is also a part of English, not commonly, but most commonly in English system, you'll find BTU. So 1 calorie in terms of joules also is given the conversion. So the conversion you need to memorize, that we'll use at the download calculation. And we have a separate topic for conversions also in this chapter 3. Okay. Next, we'll try to understand what is BTU, and it can be asked in interview also. Very basic interview question. And even for the load calculation also, as I said. So you see, BTU stands for British thermal units. It's a unit measured for energy, nothing but heat energy. And 1 BTU is defined, this is important. You see, 1 BTU is defined as the amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit at constant pressure. Once again, 1 BTU is defined as the amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit at constant pressure. So what do you think? BTU is a large amount of heat or a limited amount? You see, 1 pound of water means 1 kg. In terms of pound is what? 2.2 pounds. So I can say half liter of water, say 1 pound. And in order to increase 1 degree Fahrenheit of heat, Fahrenheit means again it's a unit for temperature in English system. In case of SI, we are using degree centigrade. So what is degree centigrade, Fahrenheit? That also you'll find in the same chapter. But as an engineer, you know these terms, Fahrenheit or centigrade or Kelvin, etc. So what do you think? This 1 BTU is a large amount of heat or just a limited?
Limited.
Yeah, because you see, 1 BTU is a heat energy which is required to increase 1 degree Fahrenheit of what? 1 pound of water. Okay, so it's a very limited amount of heat energy at constant pressure. So here, this example will help you. You see, this is very simple. 1 pound of water in a container, 1 pound of water in this container here, and initial temperature, say 50 degree Fahrenheit, for example. And after this, I'm going to add the heat. And how much heat? Say 1 BTU. So when you add 1 BTU of heat energy in this container, which is of capacity 1 pound of water, so what will happen? The temperature will increase from 50 to 51 degree Fahrenheit. Okay. So 1 BTU of heat energy is responsible to increase 1 degree Fahrenheit of 1 pound of water. That's it. So in English system, we can say the specific heat of water is what? Yes, online 1, because specific heat is what? Specific heat na, for unit volume to raise 1 degree Fahrenheit. That is a specific heat. So here 1 BTU is what? 1 BTU is a specific heat for water to increase 1 degree Fahrenheit for 1 pound of water. So here specificness, so we are considering a unit volume and for 1 degree Fahrenheit. So remember, this will use at the time of calculation. So specific heat of water in English system is 1, right? And it's a very, very basic and important for interview point of view. So you must memorize this definition. You see 1 BTU is the amount of heat energy required to raise the temperature of 1 pound of water by 1 degree Fahrenheit at constant pressure. Next, so we'll deal with one example. Here you see, simple example. So you know this 1 degree, to increase 1 degree Fahrenheit for 1 pound of water, 1 BTU is required. Now in this example, you see initial temperature of water says 70 degree Fahrenheit, 72 degree Fahrenheit. I'm interested to increase this to 82 degree Fahrenheit. Means how much I'm interested to increase? 10 degree Fahrenheit, right? Because the difference is 72 and 82 is 10. Na? Of what? For what? For 10 pound of water. So what do you think? How many BTUs of heat energy is required? We have 4 options. 1,
100.
10, 100 or 1000.
100.
Yes, online? I got the
100.
answer 100. What about other participants?
100.
So 100 is the correct. Why?
Because mass is 10 pounds.
Right. And even the degree also it's 10. So 10 into 10 is what? 100 BTUs are required. In case if I consider 1 pound, then 10 will be the correct answer. Okay. But if here the content is a 10 pound, na? So that's the reason 100 BTUs are required. Very simple. But try to understand the concept, because this will use at the time of load calculation. Because the time of load calculation, when we deal with the heat gain through wall, heat gain through partition, floor, ceiling, ventilation, etc., that we are going to calculate in terms of BTU per hour. So you can understand, this 1000, 2000, 3000, 5000 BTUs per hour heat is entering from outside to inside through this wall or through this glass, etc. Okay. So that's the reason this basic is very, very important. Hope you got the idea online about this BTU, British Thermal Unit.